It's API Days Helsinki and North again. And now we are continuing on stage one from the point of view of data ecosystems and interesting topics, continuing from Pia Erkenheimo's keynote and thinking about the business potential of different industries and data and technologies. So I invite on the stage with me Tapani Stjernvall from Bitcomp, and you are going to let us into satellite data and forestry industry. So that sounds really interesting. Are you ready?
I am ready. Thank you, and good morning, everyone. So I will talk a bit about forest industry and forest ecology, and how satellite information and artificial intelligence can solve some of the problems within that industry. As some of you may know, there have been some quite catastrophic damages in the forests in Central Europe during the last couple of years. So in, for example, 2019, 32 million cubic meters of forests were damaged by insects in Germany alone. And to put this into perspective, the annual loggings in all of Finland are around 70 million cubic meters. So over half of that amount destroyed completely by insects. In 2018, 110,000 hectares in Germany were destroyed by bark beetle. Some of these problems could be avoided by reducing the risk of the bark beetle infestations. These forests that have been planted some 50 or 30 years ago and never been thinned are growing too tightly. So there is only a small patch of green at the top of the forests, and the amount of green mass is not enough for the tree to fight, to create sap, to prevent the bark beetle from entering its trunk. If we would be able to see in advance that there is a risk of bark beetle and create these actions to tend the forests, do these thinnings for the green mass to be able to grow, we would be able to prevent these massive damages. And the impact of this would then be that instead of becoming a source of CO2, the healthy forests would instead absorb CO2 from the atmosphere. They would remain in recreational use, and of course, from the ecological point of view, it's much nicer to see healthy growing forests instead of destroyed ones. And from economical point of view, the price of the wood has fallen catastrophically also in Germany, so the forest owners are losing quite a bit of money because of these incidents. So what we can do is we combine the satellite technology and artificial intelligence. We work in collaboration with the European Space Agency, utilizing the satellite images they provide, and also we have a R&D project that is partially funded by ESA. Our self-learning artificial intelligence engine combines also other information, other data sources, weather, some GIS information, and then of course the satellite imagery. And we continuously update automatically the satellite imagery we get from the ESA. So our system automatically detects if there is an updated image from the satellite, and uses this kind of cloud masking to see if the image is clear enough. Basically, if it's less than 10% of cloud coverage, then we update the image to our system. Currently, we have 3 applications that we use. First is a change detection, where we can spot cleared areas, and we can spot already happened storm and insect damages. The second is that we have this forest vitality solution. We can detect both areas where an increased risk of bark beetle infestation has happened or is about to happen, and we can also spot potential locations where thinning might improve the health of the forest. And thirdly, we can estimate the biomass of a certain area, forest area, and we can estimate the expected growth in coming years and how much carbon this growth would mean for the environment. So the growing forest is the only one that is actively absorbing carbon from the atmosphere. If we look at these in more detail, first the change detection. On the upper picture, you can see a storm that hit Finland a bit under a year ago, last summer, called Paula. We always give names to the storms, so this was a Paula storm, and it fell about 2 million cubic meters of forests in northern Finland. And our satellite AI detection system was able to detect the areas in the map and put them on the map where these damages happened. And I believe that they are still clearing some of this damage, because the storm damaged forest is very, very difficult to clear, because the trunks are on top of each other, crisscrossed all over the place, and some are leaning on other trunks, and it's very dangerous and risky business to clear these damaged forests. The second image on the bottom is one that we have in operational use with the Finnish Forest Center, where we detect automatically the loggings, clear cuts and thinnings, and we put them on the map, and the Forest Center can then automatically compare them with this forest inventory and see that these loggings and especially the clear cuts have been made according to the notifications sent by the forest owners. Basically, this is a system to detect that no illegal loggings are happening within the whole country. Now, this forest vitality is a solution that is currently being piloted, and we already can see that it works. And the plan is to put this in use in Germany. The problem in Germany, on top of these damages from bark beetles because of the climate change, is that the forest ownership in Germany is very fragmented. There are around 2 million private forest owners in Germany, and the ownership is such that they can, for example, own a very small patch of forest, and they don't even know where it exists. So we have developed an application for the forest owners to see the location of their forest patch, and then we can also detect the forest vitality. The AI is quite interesting that it can detect the hitting water stress level of the tree even before a human eye would see anything different in the optical image. But the AI, when it's taught, it can detect these changes, and then through the system we can inform the forest owner about the condition of the forest, and potentially the authorities or forest service companies can then do some preventive actions, or at least try to contain the damage to a smaller area, because the bark beetle infestations have a tendency of spreading over vast areas. So if we can even maintain the damage to a smaller portion, that would be a huge help for the whole of Germany. And then on the other is the proposed maintenance recommendations. This one we also have in operational use here in Finland, with the forest owner associations being able to automatically detect these areas where thinnings or other maintenance services would be required, and they can offer them for their customers or forest owners. So it automates the sales process for the associations. And then thirdly, we are in a phase of building this biomass estimate solution. So far we have a POC, proof of concept, and we know that it does work, but it needs to be, or the artificial intelligence needs to be taught if we move into a new geographical area where the forests have different species and different kind of growth patterns. We need to re-educate the AI to understand it. But it is a proven technology, and we can estimate the biomass and create this kind of a automatic segmentation where we can see that different patches of forest, typically where the main species is dominant, for example, a spruce or pine. If we compare this for the manual work, on the left there is a patch where the manual forest professional has estimated that there are 515 different stands, meaning different kind of patterns, and they have estimated that this area contains about 109.5 cubic meters per hectare of forest in average, and this takes the forest expert about 1 week of work time. Our artificial intelligence also did the same thing for the exact same geographical area, and it came into conclusion that there were 498 stands. So about seven stands difference to the forest professional. It estimated that there is 115 cubic meters per hectare forest in this area, and it took about 1 minute to come into this conclusion. So you cannot even say that did it make wrong conclusions, because the estimate that the forest professional does is also an estimate, so it's not completely accurate. But the AI came in very close, same result in 1 minute, whereas it took 1 week from a human being. On top of this, we can then calculate the expected growth of the forest in this area, and from that we can calculate how much carbon is being stored to the forest during its say like next 10 years growth time. As mentioned, we combine the satellite data with our AI models and training data, and currently the European Space Agency's Sentinel satellite provides us optical data with 10-meter resolution, but even from that we can get the basic forest variables and carbon storage and other variables. So for the typical planning of forests, this is quite accurate enough, the 10-meter resolution. The challenge with optical data is that, of course, whenever it's cloudy, it doesn't work. It does get updated fairly frequently. Whenever the satellites fly by, it's global, so we can do this basically anywhere in the globe, and it's frequent enough for planning or the forest planning actions. There is also an alternative, the SAR, the radar data from another satellite, which doesn't care if it's cloudy or dark, but the resolution is quite not good enough for most of the things that we need in this solution. The resolution is about 15 meters. So for especially the quick detections of storm damages or bark beetle damages, the frequency is and the accuracy is not good enough. There has been discussions and plans also for detecting risk of forest fire, and we may build that POC next in our roadmap. But the problem again is that if a forest fire starts, we don't get the data quick enough through this system. But of course, the satellites and technology evolves quite quickly. So who knows, maybe in a couple of years we have data that can be used for also more accurate, more on-time detections of things. I will just very quickly go through these tools that we have currently, where these solutions are being used in forest planning and forest management tools we have in Finland and Germany. But basically, like mentioned, the AI solutions can be used globally as long as we get the teaching data for the AI. We have our own geodata services. We have our own map engine. We have tons of different background maps that we can use, and we enhance them with our satellite analysis, and we have standard APIs, WMS, WFS APIs for the map layers. And we calculate a vast amount of different parameters that can be used then by the forest managers. Also, we have quite big ERP systems. The Finnish forest owner associations are using our tool as their ERP. We have tools for forest management by different organizations, cities, municipalities in Finland. And then we have a solution for procuring wood used by the large forest companies in Finland. And all of these can then also be used in mobile applications. So when the foresters actually go to the forest, they can bring the solutions with them. Very shortly about Bitcomp. We have about 75 employees, 5.6 million euro revenue from last year, quite rapid growth for the last couple of years. We do projects, software as a service. We have our own products, and we invest quite a lot in R&D. And some of the major customers consist of the large forest companies in Finland, as well as public sector companies. And if I'm not mistaken, I have about 5 seconds left of the presentation. So thank you very much. And if you have any questions, then feel free to ask. Thank you.
Yes, great. Thank you, Tapani. And there was already midway your presentation, there was already eager beavers in the audience asking, "Where's the API?" And I said, "Well, it's coming, it's coming." So, so are you using APIs mainly for the like satellite and geospatial data, or also internally, or somewhere else in the AI part of the solution?
Yes, we use APIs. The whole system is being built modularly. So the AI collects data, and we use APIs to for the business logic to utilize it. But like I said, we can separately also share these map layers via API, and we are using standard APIs. Then on the more complex ERP models, we have APIs to connect to different financial systems, for example, and CRMs.
Yeah. Can you explain a little bit about that W stuff in the APIs? I know they are used in geospatial world a lot, but the audience might be more used to REST APIs. So what's going on there?
Yeah, we do use REST APIs as well, by the way. So standard way of this database usage. I'm not a GIS expert myself, unfortunately, so I cannot tell exactly what the abbreviations mean, but they are the standard form of sharing and using map layers in different GIS solutions. So we could use the same map layers that we provide in, say, Esri's system or any other map provider's system. And for example, the Maanmittauslaitos that was here earlier, they distribute their maps with these same standard formats.
Yeah, National Land Survey is using those APIs, and also the National Meteorological Institute is using the same kind of APIs for their weather data, while they are also having more RESTful APIs. So it's kind of like it's like a little bit of like old versus new standards, but also a little bit different use cases. So the other one is more like the older one is more suitable maybe for very professional use cases and heavy duty integration, but the new ones are more easier to understand for everyone.
Yes, one API that might interest the audience is that we have been developing this forest data standard for a decade or more in collaboration with the Finnish Forest Center, and currently all the different forest players in Finland have a standard way of distributing forest information, and they are used by, for example, sending information about the loggings and plans, and there is a standard API where all the different players can send information, and they even have this Kuutio product now, where the forest owners can create these public biddings to see which company would procure wood from their forests.
Which is kind of related to also the strange way that the Finnish forests are being owned and managed. Isn't that so?
Yes, in a way, but there is quite a lot of private ownership, but the way wood is procured is quite different than it is in central Finland. In Finland, the forests are typically sold standing, so the company procures the logging rights, whereas in Central Europe you actually log it and deliver the wood to a sawmill.
Which I wanted to just raise up because it is tying up with our earlier discussions this morning in the keynotes with the business models and business cases and the business models of your API consumers versus the business models of the API providers. And there it matters, not just who owns the API or provides the API, but also who owns the forest, which is then related to the API. Thank you. I think it was really interesting and a bit different approach to APIs and data than maybe some of the other talks. So thank you a lot, Tapani, that you had the possibility to join us today.
Thank you very much. My apologies for the lack of APIs in this presentation.
No, I think it was just the right level of APIs, because trust me, I've tried to use those whatever W standards of APIs they are. And yes, let's